Welcome to this lecture. As we have seen on previous lecture that how the Newton's forward interpolation formula was developed. Before developing the Newton's forward interpolation formula, we have seen the various basic concepts of the interpolation, and thereafter we developed the method which can estimate the value of the function, and also it can estimate the extrapolate the value of the function, but there are certain restrictions laid down by this method. So today in this lecture, by giving this lecture, I think the concept of the Newton's forward interpolation formula would be quite clear, and therefore from that point of view, two important applications in the form of numerical examples have been designed to present before you. We have seen the numerical uh, applications of the missing values too. There we applied the Newton's binomial expansion formula, but here it is this application is wider application and very frequently used in the various sciences of various branches of science, engineering, and technology, including the applied sciences. And therefore, we are going to start two important applications. As we know that the function is approximated by the polynomial, and polynomial has been developed with the help of the Newton's formula, and that Newton's formula is nothing else but the approximation of the function given in various form of the polynomial, and therefore we are going to present two important examples here, and after this example your concept will be clear. So the first example which I am going to present before you, with the assumption or with the anticipation that you must have remembered the previous formula which developed on previous turn. From that point of view, look at this problem. Newton's forward interpolation formula means Newton's forward difference interpolation formula, as I have already explained this. Look at this example. For a function y is equal to fx, this function is as usual function which is approximated by the polynomial that is known as interpolating polynomial. The tabulated data is given as tabulated data is given means there are values of xi and values of yi. Xi ranges from 0, 1, 2, 3, 4. There are 5 values of x, and similarly y corresponding to given value of the x, that is independent variable, or that is also popularly known as argument. The y has value 1 and y has value y2, y0 1, y1 7, y2 23, y3 55, so forth, so on. Last is 109. So find the value of y for x is equal to, you just note this point, please have this, be mindful about this very value. This value is what? X is equal to 0.5. X is equal to 0.5, where it is going to lie. You look at here, it is going to lie somewhere. This is 0. This is value of the x 0. This is value of the x 1. So where it is going to lie, it is going to lie 0.5 is here. Please Note this very point. It is lying in between 0 and 1, but its value is not given. Its value is not given. Its value has to be estimated or approximated. And if you remember the concept of the Newton's forward formula, the two is strictly laid down or restrictions by the Newton's forward formula were what? These were the first restriction, that the estimated value or estimable value must be in the beginning of the initial value, must be in the beginning of the initial value, and therefore this 0.5 is obeying that restrictions, means this is not violating the restrictions laid down by us. So in this way it is okay. I think whatever we have read, that the estimable value must be near the initial value. So this is the initial value of the argument. This is initial value of the function. 0.5 is near to this beginning value, near to beginning value. So from that point of view, it is okay. Okay, you look at here, since given value x point, you have to write, you have to mention this thing whenever you are solving your numerical, you have to justify it, because the application of the Newton's forward formula is for this situation only. Therefore, x point 0.5, x is equal to 0.5 is lying in the beginning. Newton's forward interpolation formula will be applied. This is the justification of the Newton's application. Let us form the forward difference table. Now form the difference table. This is the difference table. This is your difference table. These are the values given. Y, the first difference we are going to have 7 minus 1 6, 23 minus 7 16, 55 minus 20 23. So course 1, 55 minus 23 and 109 minus 55. So this value will be written in between this value, means 1 and 7, in between 7 and 23, in between 23 and 55, in between 55 and 109. Second difference, how we compute the second difference? 16 minus this will be in between, this will be in between, this will be in between. And similarly the third difference, this will be in between, this will be in between. So, and lastly the fourth difference is going to be 0. How many values are given? How many values are given? You look at how many values are given in your function. 1 2 1 2 3 4 5. You look at here. So up to 4 you have got the value. So this is 0. It does not mean, and 5 values are given. So polynomial, what is the order of the polynomial? Order of the polynomial is 4, and up to 4 you will get the value constant. And what will be the fifth order? Fifth order will be 0. But per chance it is also coming 0, but it is a finite quantity. Newton's forward formula, Newton's forward interpolation formula is given as this formula. You must remember, this is the polynomial which is approximating the function y is equal to fx, and this is written y is equal to phi x. Either you write phi fx, either you write y in the left, or you write phi x, but basically this is a phi x. But in most of the literatures we write the y is equal to fx. It is to be estimated. Since now there is no difference between the polynomial and function, because this polynomial is approximating the function, and therefore we directly write fx or y, and at this stage it is equivalent, but actually they are equivalent like this. But since it is interpolating, therefore you can write like this. And generally we write fx is equal to this. From here we start our summation. So the what is formula? You must remember the y naught plus u, the first basic difference, and if you want to put here, you can put here the factorial 1, and the second u into u minus 1, and then it is 1. Then you put here the factorial 2 and the second difference of y. And u in plus u into u minus 1, u minus 2 upon factorial 3. If it is u minus 2, then here factorial 3, and this is the third difference. And next, u into u minus 1 into u minus 2 into u minus 3 upon factorial 4 multiplied by the fourth difference of ui. So in this way, this is a popular formula, and you have to remember this formula. You keep in the mind. Sometimes theory is not asked how to develop the Newton's difference interpolation formula. This is not necessary that this is being asked in your examination. Sometimes directly this numerical has been asked without proving the formula. So you must remember this formula. Keep in mind. Commit to this your memory. So okay, let us go ahead. This is the formula given. Now this popular, where u is equal to, how to get u is equal to, as I told you, this was the new variable here. So how to get x is equal to x naught? X is what? The value for which we are going to compute the value. It is when x is equal to 0.5. Minus what is x naught? If you look at the table, x naught is 0. What is h? The difference between x naught, and if you look at there, the x naught is given like x naught, the x1, and the x2. If you look at your table, then you will find this is perhaps 0, and this 1, and this is 2. So what is difference between 1 and 0 is 1, and difference between 2 and 1, that is the spacing or length of the spacing is 1. So here h is equal to origin and scale. You can change this origin and scale, but here there is no need of changing. In the statistics, we use several number of times, enormous number of times this process, because we reduce the very big data into a smaller data set, and then it is easily to be computed with the help of the statistical software or the statistical methods. So x naught is 0, h1 is 1, x naught is this. So all values are given and we substituted this. After substituting this value, we are going to have again this value. Okay. This formula we are going to apply f 0.5 fx, y is equal to fx. This is y naught. We started from here, and this is what? This is u. And this is what? This is the first difference from the table. This is what? This is u. This is what? U minus 1. This is what? Factorial 2. This is factorial. And into 10, this is the second difference. This is second difference. This 10. Similarly, this is what? This is u. This is u minus 1. This is u minus 2. This is factorial 3. This is the what? Third difference. And fourth, since fourth difference is 0, and therefore without thinking much, we have put here 0. Otherwise, it would have been calculated in the similar manner. So this is 1, this is 3 point, this term is this one, this, and ultimately 3.15. So f 0.5 is equal to 3.125. 3.125. Again, I would like to show you the table, the tabulated data. You look at and be happy that we have received obtained the desired result. Yeah, look at 0.5 and 7. In between 7 and 1, we got the value how much? 3 point something? 3 point something is here. 3 point something is here. So you can do in the similar manner. Okay. So this is one way of estimating the value with the condition that the estimated value must lie in the beginning. Okay. In the neighborhood of beginning, this is a condition, neighborhood. And the neighborhood, we know, we understand in the mathematics neighborhood, it has infinite number of points. Our neighborhood, very big neighborhood, infinite number of points, not narrow-minded neighborhood. This is a very big, wide neighborhood defined in mathematics. So you can make now similarly 0.5, you can make 0.4 for the value of 0.4, you can make 0.3, so forth on. You can again make it a smaller fraction corresponding to all each and every value of x. This Newton's formula, Newton's forward interpolation formula will give you this value of the function. Okay, another, we have just to change the flavor of application. You look at it was the very usual way of applying this one. Now we have changed the flavor. You look at how we have changed the this trend by applying the Newton's formula, Newton's forward interpolation formula. You just a polynomial, a condition is a polynomial passes through following points. Interesting. Point 1, point 2, point 3, point 4. There is one polynomial which is passing. Polynomial is linear or non-linear. It is always non-linear. Polynomial is always always means it is a constant, it is a degree 1. Most of the times it is non-linear. Otherwise you can object to my statement. You are a mathematician, you can touch my tongue, I know it. So find the polynomial. Now a polynomial which we don't know, about which we don't know, but we know what? We know that this polynomial passes through 4 important points. Then what is the polynomial? Okay, there are 4 points, means we have got 2 coordinates. One is the x and another is y. It has no any doubts, no any objection regarding this. So one value is x and another value is y. So our work is, half of the work is more than half of the work is done. What? The x, we have arranged the values of the x and y in this way. You look at x is equal to 2, 3, 4, 5, and corresponding to this -2, -3, -2, and 3. Computed the first difference, the in between this, the -1, in between this, +1, in between -2 and 3, this is the 5, and in between the second difference, in between this is 2, I mean here is 2, in between 5 and 1. Okay, so this 5 and 2, this is 4, and similarly in between, now the next one, this is 2, 2 and 4, in between this is 2, this is third difference, this is third difference, and fourth difference is 0. Again we have got here the fourth difference is 0. So if fourth difference is 0, then there is now only one element and we have got a constant quantity. So we need not going the next one. We need not going the next one. Okay. Forward formula used here in Newton's forward difference interpolation formula. Now this y is equal to, here y is equal to r, y is equal to fx. This formula is written again and you must remember it. I have remembered while teaching you this formula. And this here x naught is 2, h1 is 1, and x is equal to x. I mean to say, the here for your convenience I have written like this. And u is equal to x minus 2 upon 1 by applying the x minus x naught upon 1 initial value. So u has come out not concrete value but involving the x. You look at. Since we want to have the polynomial and therefore it is involving the x, that is independent variable. Okay, solving it, y is equal to this as y naught, this was y naught, this is u minus u, this is the first difference, this is the u, this is the u minus 1, this is the second factorial 2, and this is the second difference. This is into 2, this is into 2, and this into may be confusing. This is not x, this is into. So x minus 2, this is the u, this is u minus 1, this is u minus 2, this is factorial 3, and this is the into 2. This is the third difference of the polynomial. You look at, after solving, minus 2 is here, minus x minus 2 is here, simplified in this way, it is elaborated, hereafter simplified, and as usual this is elaborated and then involving 3 factors, so multiplied and simplified. You look at what we are going to have. After solving, we are going to have 1 by 3 x square and 2.67 simplified is equal to y is equal to, means fx phi x polynomial is this. Degree is how much? You look at here. You look at here. x3 degree 4 degree 3. So this is a polynomial of degree 3. So we can also get the polynomial with the help of using this formula. So in this way, I think now this we can also extrapolate this one. But while making the extrapolation, what is the restriction? That the extrapolable value must be near, little bit near, not little bit near, little bit left to the initial value, not near, little bit left to the initial value, or little bit backward of the initial value. Backward, if you want to extrapolate, suppose you want to apply for extrapolation. I just take this example, little bit. I mean, this is x naught. So extrapolation can be made somewhere here. You look at somewhere here we can extrapolate. Means for this is 0. So less than 0 is what? Less than 0 and minus 1, you can take any value. Minus 1 is after 0 and here is 0. So you can just take any value in between this, any value, whatever you want, and you can extrapolate Newton's with the help of the Newton's interpolation, Newton difference interpolation formula, forward difference interpolation formula. So this, but condition is the little bit left, means if you say minus 2, thereafter minus 2, minus 3, so I'm going to have around minus 5. No, this is not going to give you the correct nature of that value. It will give you the accuracy with the highest accuracy If this condition is followed, what is the condition? Condition is little bit left to the initial value or little bit backward of the initial value, then approximated value, then extrapolated value will be having the high accuracy. I think your concept may have become clear. Now we are going to stop the lecture for